here I have 2x squared plus 2y squared plus 2z squared equals 8x minus 24z plus 1. And what would kind of clue me in that this is a sphere is that I have x squared, I have y squared, I have z squared, and those are the highest exponents that show up. But not just that, something else is going on this problem, that each coefficient in front of x squared, in front of y squared, in front of z squared, they are the same. If they were different coefficients, I couldn't say that this is a sphere. But it is a sphere. And one thing you could do to try to determine if it's a sphere is go ahead and try to get it in the form, in the, I want to say standard form. I don't know if they call it standard form or not. Is get it in that form that I mentioned yesterday. So let me write this. So I want to put this equation in the form, if it's possible, x minus h squared plus y minus k squared plus z minus l squared equals r squared. And I made it sound like if it's possible, if it's the equation of a sphere, that is possible. What you have to do to get this in the form for where I can have the center HKL right there, the radius right there, is you're going to have to complete the square. And to complete the square, I'm going to take this, I'm going to move 8x over, I'm going to move 24z over, and I will put 8x, in fact it's going to be a minus 8x. I'll put the 8x next to the 2x squared, and then I have plus 2y squared. I don't have anything over here with y to the first power or anywhere in the problem, so I'll just leave it plus 2y squared. And then plus 2z squared. This will be plus 24z equals 1. So from the 1, I will get the makings of r, although that's not r at this point. Something else about this problem, to get it in this form, I've got to do something about these 2's. What do you think? Divide everything by 2. So, not just the terms that are squared, divide everything by 2. Even that 1/2 now. So, I'm going to end up with x squared minus 4x plus y squared plus z squared plus 12z equals 1/2. Then comes the complete the square step. For the complete the square step, I kind of like to do this way. X squared minus 4x, I'm going to group those together, plus some blank, plus a number that will let me factor that into a perfect square. And now y squared, I don't have to worry about y squared. I know the y coordinate of the vertex is going to be what? It's going to be 0. And then I'm going to group together z squared plus 12z plus some number. That'll let me factor that into a perfect square. Now, I think about my 8th grade teacher right now, because he would say, you cannot change the problem. You cannot change the problem. So if I add something to the left side, I've got to do what? Add it to the other side. So I got the blank with the x's, I got the blank with the z's, so over here in these blanks, I will fill in whatever number I put to complete the square. Well, to complete the square, whatever's in front of x to the first, as long as in front of x squared you have that 1, whatever's in front of x to the first, we'll take that number, cut it in half, and square it. So 4 over 2 is 2, and 2 squared is 4. This blank is a 4, this blank is a 4. We'll do that again with the z's. In front of z to the first, I have a 12. 12 over 2 squared, that's 6 squared, so in that second blank I put 36. Or the blank with the z's here, I'll put 36. And now I can factor. This will be x minus 2 squared plus y squared plus z plus 6 squared. Now 4 plus 36, that's 40. So this is 1/2 plus 40. Well, I'll just write that 1/2. 40 is 80 over 2. So I will end up with this. X minus 2 squared plus y squared plus z plus 6 squared equals 81 over 2. So the center is, the center of this sphere, 2, 0, -6, and the radius is the square root of 81 over 2. You could leave it like that. If you like, 9 over the square root of 2. And if you're in a situation where they say and rationalize the denominator, 9 times the square root of 2 over 2. If any of these for the radius would be just fine. And then the center. Okay, any questions on that problem?